So hello everyone, my name is Shubham Aranya and today I am representing the Golfer, a smaller LM generated document hallucination filter and the combiner for the query expansion in information retrieval. So today this is the outline of the today's session. Let's deep dive into introduction or the problem of current world. So the query expansion in information retrieval is one of the important part in LLM. There are two types of category in query expansion. One is traditional approaches and the second one is LLM based approaches. The traditional approaches are the WorldNet and the external text collection, right? The limited by the data quality. LLM based approaches are the generate the hypothetical document where we get the better approach and where exactly our golfer is comes, right? So what is the limitations of the current LLM based methods? So dependency on the large models, high cost, the computational intensity and the smaller LM issue which is produce hallucination and the factual errors, right? So the question is, can we use our smaller LM for the text generation without that hallucination and the factual errors, right? So answer is yes. By using golfer we can achieve the best or the hallucination free and the factual error free output using the golfer. So there are the two component in golfer. The first one is hallucination filter and the second one is document combiner. So hallucination filter detect and the remove the non-factual and the inconsistent sentences. The document combiner combines the filter content with the original query using weight vector. So this is the flow of the query. How the flow of the query works? The query goes to first we give query to LLM that generates the end passages and that will filter the hallucination and then combine with the query and enhance our retrieval, right? So first, hallucination filter, how the work? It is a factuality score. The core principle is the factual statement have tokens with the higher likelihood and the lower entropy. So we have to find the which statement has the higher likelihood and the lower entropy. For that, we'll use the step one. First, we find the token uncertainty using entropy. The second one is the token influence, which is self attention. For that part, we have to use a white box model. The step 3 is a token factuality score, and the step 4 was the sentence level factuality score, which we can which we- which we can calculate using the token factuality score. And step 5 is the consistency score, and this is for this we use the NLI based method, NLI based models for calculating the consistency over the sentences, right? And the final filter score is HSIJ is equal to FSIJ into CSIJ, which means sentence factuality score into the consistency score. If we find the filter score is greater than 0.8, so we'll filter out this statement, particular statement. If it is less than 0.8, we'll go with that sentence. So second part was the document combiner. For that we can use the sparse retrieval or the dense retrieval. The sparse retrieval with direct term weight combination. The query repeats 20 times for this particular and the balanced query versus document. In the dense retrieval, the embedded based combination where we use the beta equal to 0.6 for the query contribution and the generation confidence weighting. The experimental setup. The first we took the language model is Llama 3 8 billion instruct. Setting was the temperature we set 0.6 and top P is 0.9. The max token was 128. The NLA model we used dbart v3 large. For dataset we use two categories of the dataset. First one is the website dataset and the second one is low resource dataset. For the baseline we use the sparse, dense, and for the query expansion we use Heidi and the query to doc. So when we evaluate our model, we find that on when we use golfer on the website database and MS Marco and the TREK deal, right? So that time we can find that the golfer outperform the all other models in most of the cases, right? So golfer constantly outperform the other model using smaller LMs. Significant improvement across all metrics. that works well with the both sparse and the dense retrieval. So let's move on to the low resource task, where you use the 5 different types of datasets, small datasets of the part of the beer, and that time we use the matrix NDC at 10 and recall at 100. And that time we also find that the golfers show the consistent improvement across all the datasets, demonstrating the effectiveness in the diverse domain. So see, we used two part of the data set, right? So we also evaluate our model with only filter, with combiner, and with both. So there we find the interesting results, right? With filter we didn't see that much of improvement. With combiner we see good amount of improvement. But when we use the combined approach, we achieve the best overall performance. So so only alone cannot work better. If we use the both combined approaches, we achieve the best overall performance. So, and then we also evaluate our model versus a large model, and which is our objective of that particular this paper, right? So we we use the llama 338 billion for our golfer, and the large model GPT 440 for the other parameter height d, right? So we calculate this and the four different data set, and where we get the interesting result, right? In the two of the data set, even golfer with the llama outperform the GPT-4, and this is very interesting, and that's what we want. The golfer with the smaller LM is competitive with and sometimes outperform the method using GPT 4.0. The advantage is a much lower cost, no regional restriction, and the faster inference. So now we move forward and see what the contribution and the impact that paper brings. The novel approach, the hallucination filter, the document combined, and the strong performance comparing to the larger LLMs, right, which is 20 or 30 times bigger than the smaller LLMs. Still, we can beat them in some of the areas. And the principal practical benefit is cost-effective solution for IR system, lightweight and versatile. No additional training required, and the limitations and the future was also there, right? As we have pros in this golfer, as we have one cons of the paper also there. So it is depending on the self attention, as I discussed. It is totally dependent on the self attention. So we have to use a transfer based LLM where we can get the self attention, right? We cannot use directly API where we don't have the access of the self attention, right? So we have to use a transfer based LLM where we have the access of the self attention. So what will be the future work on that particular data? So we'll develop the alternative approach for the APIs without attention score access. So explore the other hallucination detection method and extend the multi-layer settings. This is the code repository where you can go and find out the how we can calculate the evolution part and how we calculate that comparison with the other models, right? So that's it for today. Thank you so much. It's my time. If you have any questions or any doubt, please feel free to ask me uh, on my LinkedIn page or anywhere else. Thank you so much for having me. Have a good day.